Hello everyone, welcome back. Today I'm going to explain a problem on design for shears. A support section of a PSC beam 100 mm wide and 250 mm deep is required to support ultimate shear of 60 kN. The compressive pre-stress at centroidal axis is 5 Newton per mm square. FCK is equal to 40 Newton per mm square. If the characteristic strength of the steel on stirrups is 250 Newton per mm square, design the suitable reinforcement at the section using IS 1343 specifications. Here the diagram is not given, so we should draw a rectangular section which is having 250 mm deep and depth is 250 mm, width is 100 mm. Next is we should write down all the data given. If they have given the diagram, then this 50 mm cover would have been given. If they had not given also, just assume the effective cover has 50 mm. It is measured from the center of the cable to the bottom. So that much is a cover given. So if we know the cover, we can find out dt, that is 250 minus 50, we will get 200 mm. Write down the data. Shear force is 60 kN, FCP compressive pre-stress is 5 Newton per mm square, FCK 40 Newton per mm square, cover is 50 mm, therefore we will get dt has 200 mm. Next is a calculation of external shear force. External shear force, they have given it as 60 kilonewton. So observe the question carefully. See here, ultimate shear of 60 kilonewton, ultimate shear word they have used. So you need not to multiply 60 into 1.5, you need not to multiply with a factor of safety. So don't do that. Be careful with the question. So directly it has been given ultimate shear force is equal to VU is equal to 60 kilonewton. Next is internal shear resistance. Internal shear resistance VCO is equal to 0.67 BD into whole root of FT square plus 0.8 FCP into FT plus P sin theta. I'm sorry here, there is a typing mistake. Here P sin theta is not there at all. They have not mentioned anything regarding the cable profile, parabolic, nothing like that. They have not given theta value also. So don't add P sin theta directly. You just consider this formula. This is for a straight cable. Next is, let's check whether we know all the terms or not. FCK, it is given. So using this FCK equal to 40 Newton per mm square, we can find out tensile stress. Tensile stress formula is 0.24 into root of FCK. We will get 0.24 into root of 40 is 1.52 Newton per mm square. Next is everything is done. FCP is ready, FT is also ready. So substituted, we will get 0.67 into 100 into 250 into whole root of 1.52 square plus 0.8 into 5 into 1.52 is a value. So therefore VCO is 48.45 into 10 power 3 Newton. If you want to convert it into kilonewton, we will get VCO as 48.5 kilonewton. So there is a comparison here. You should go and check back with the values of VCO and VU. How much is VCO? It is around 48. How much is VU? It is 60. It is clearly understood that VCO is less than VU. So in this condition, we should provide shear reinforcement. So I'm just assuming, or I'm just using two-legged 8 mm vertical stirrups. For these vertical stirrups, we should find out the area of the stirrups. So notation is ASV is equal to two-legged means 2 into pi into d means 8 mm. So pi into d square by 4, we will get ASV has 100.53 mm square. Next is we should find out the spacing of these stirrups. So we should use this formula, that is ASV by SV is equal to VU minus VCO whole divided by 0.87 Fy into dt. ASV 100.53 by ASV, that was a ASV whole divided by SV is equal to 60 into 10 power 3 minus 48.45 into 10 power 3 whole divided by 0.87 into 250 into 200. Therefore, spacing of the stirrups is 237.65 mm. Next is calculation of minimum shear. So we have a formula ASV by B into SV is equal to 0.4 by 0.87 into Fy. Substitute the values. ASV 100.53 by 100 into SV is equal to 0.4 by 0.87 into 415. If they have given Fy value or grade of the steel means, take it as 415. If not, just assume it as 415. Therefore, we will get SV has 907.40 mm. Two minimum value is over. Next, we should check for maximum spacing. The spacing should not be more than this. So the standard formula according to the codebook IS 1343 is 0.75 dt or 4BW. So for 0.75 dt, we will get 550 mm. dt is already we have calculated. So take that value, we'll get 150 mm. For this one, we will get around 400 mm. 4 into 100 is 400 mm. This is a value. So let's see the conclusion. The conclusion is taking least value. Don't get confused. We have considered two least values here. So the first value was around 237, second 900, 150, 400. If we want two minimum value, the first value will be 150 and first value will be 150 and the second value will be this one, that is 237. So we will go according to that. For see here, provide two-legged 8 mm vertical stirrups at 150 mm center to center near support. The first least value or least spacing I am just using for the supports, for the left support as well as for the right support, and at mid span we should consider second least value, that is you can decrease the spacing. So I am just rounding it off to 230. So 230 mm center to center at mid span. We should provide two-legged 8 mm vertical stirrups at 230 mm center to center at mid-span. Like this, we can design it. Hope you have understood. Thank you.